Hi everybody, I have had a request to explain question 2F on the reference circle. So this is question 2 and I'm going to explain how to do part F. Okay, so just a couple of things that we need to know in order to do part F is just this first part. So a particle moves in vertical simple harmonic motion with a period of 1.5 seconds and the amplitude is 1.0 meters. Now at the start it is at equilibrium and it's moving upwards, and what we have to do is we've got to figure out what happens when it's 1.75 meters below equilibrium and it's moving downwards. What do we have to do with that? Question 2F says calculate the angle theta when the SHM particle is 0.75 meters below equilibrium and moving downwards, and we also have to calculate the time it takes for that simple harmonic motion particle. So I've kind of worked it out. So this is reference circle 2F. So here's a scenario. So there's your at the start, so that's when time equals 0, your reference particles here, your simple harmonic motion particles here. So it starts moving, and so the simple harmonic motion particle initially goes all the way up and comes back all the way down. It keeps going, but this is the position we are looking at. So in that time, the reference particle goes from this place, goes all the way to here. So the angle through which it has moved is this big angle, okay? And 0.75 meters below equilibrium is this blue line. All right, so we know that in order to calculate the angle, we know that from here to here is 180 degrees. So if we calculate this extra bit and add to 180, we'll have the angle. So in order to calculate this extra bit, I've just kind of drawn it here, is I just converted that to a parallelogram. So this blue line is the same as that. It's 0.75 meters. The length of this phasor, displacement phasor, is the amplitude, which is 1 meter. So here's your right angle triangle. So you've got opposite and you've got hypotenuse. You know both those. So it is sine theta is 0.75 over 1.0. So theta is sine inverse of 0.75 over 1, and you get 48.59 degrees. And in order to figure out what's the total angle through which the reference particle has moved, you've got to add 180 to it and you get this number. Okay, so that's the angle. And then the next part is how long does it take to do this? To calculate the time, the important thing that you need to know is the period. Now the period is the time it takes to go 360 degrees. So using proportion method, so in order to do 228.59, how long will it take? So you just go 228.59 over 360 times 1.5 and you get 0.95 seconds. And so that's the answer to question 2F, and I hope this makes sense. So bye for now.